Welcome, viewers, and thank you all. Thank you all once again to our online channel of the Regional Science Center and Planetarium Calicut. You can understand that we are here online once again after a few days. It's because we all were in some sort of understanding that we are winning over this pandemic, and we started operations. People started coming into our science centers once again, and we thought slowly we are limping back to normal. uh, I don't know how scientific that idea was, and how correct were our states. But then we were struck with this huge second wave. 100 years back, we can remember, historically speaking, it happened in so-called Bombay fever or the Spanish flu infection also. The first wave passed by. It was not that severe, but it is said that the second wave was much more severe, and something that is grappling us today now in India once again. Uh, we are into a situation where we are having almost 3.5 lakhs new cases per day on the average, and for last 7 days or so. And at the same time, we have lost about 2 lakh of our fellow countrymen, and that is terrible. That is terrible indeed. And in such a condition, we want to decode the dynamics. What is happening? Which way we are going? Where did we lack really, if at all? And then I know there are data deluge in the WhatsApp, in the popular newsprint media, but there's a problem of authentication. There's a problem. How do we benchmark that information? So that's why we thought that it would be most appropriate to talk to one internationally renowned virologist who is deeply involved with this pandemic tackling in India, and he is also following and monitoring the whole situation. We have here today with us Dr. Shahid Zamil. Welcome, sir, and thank you very much for giving time to us. We are very much thankful to Dr. Jamil that he has agreed to talk on this point, to demystify all the issues involved and to clear out our ideas. What it is there a second wave? What is happening with Corona in India? I'll just give a brief description. He needs very little introduction, or perhaps none at all. But even then, since it is formal, I'd like to give a formal introduction to Dr. Shahid Zamil. Dr. Shahid Zamil is an internationally renowned virologist and academic. He is currently the director of the Trivedi School of Bioscience at Ashoka University. Prior to this, he was Chief Executive Officer of the Wellcome Trust DBT India Alliance. He did his PhD in biochemistry from Washington State University and his postdoctoral research in molecular virology from the University of Colorado Medical School, USA. Before joining the DBT Alliance of Government of India with Wellcome Group, Dr. Jamil was group leader of virology at the International Center for Genetic Engineering and Biotechnology, where his research focused on the hepatitis E virus and HIV. He has published over 130 papers and served on various review and advisory committees of the Government of India and the World Health Organization, WHO. And we are so very happy also to declare that Dr. Zamil has been associated with our National Council of Science Museums for a very long time. He was a member of the Executive Council of our North Zone headquarters, the National Science Center, Delhi. Dr. Zamil received the Shanti Swarup Bhatnagar Award in Medical Sciences, which is India's highest science research award, and he is a member of all 3 science academies in India, that is Indian National Science Academy, the Indian Academy of Sciences, and the National Academy of Sciences, India. The forum is all yours, sir. You may kindly begin, and after you present your views and visions, we will have a short discussion. We can also take some questions from the viewers. Sir, it's all yours.
Thank you very much. Thank you very much, Manush. Uh, I'm getting my echo back, so everyone else will have to mute themselves. Yeah, is better now. Thank you, Manish, for the invitation. I go back about a year, little more than a year, I think in February last year. My very first engagement on COVID was at the National Science Center in Delhi, where they had put up an exhibition on coronavirus, the novel coronavirus. And we had a BBC program filming at the museum there. So that was really the first engagement I had with COVID. And in my wildest dreams, I did not believe that a year later, we would be in such a dire situation as we are today. Very, very unfortunate. It's a really tough time for all of us. But let's try and understand about this Indian outbreak and about the virus and about the vaccine. Uh, so what I plan to do is spend maybe over the next 30 minutes uh, formally talking about the way things are, the way I see things, and then I'll be happy to take questions. So let me start presenting my slides. Um, and one of you will have to just tell me whether my slides are visible to you or not. Are my slides visible?
Okay.
I've put it on the view mode. Okay. So if you don't find my slides to be moving, please shout. All right. So I'll talk about the COVID situation in India. This is the current status, and you will notice that this status is just 10 minutes back today. The world has crossed 150 million infections. A little over 3 million people have succumbed to this infection. And the most worrying part for us in India is that we have moved into the number 2 position with almost 18.7 million, 18.8 million infections and over 208,000 deaths in the country. Now, if you see the yellow graph at the bottom right corner, you will notice that the global outbreak grew to a point in the third quarter of last year, and then it started coming down. But from about February onwards, it started peaking up again. Now, this is the global picture. But if you look at the sort of the second wave in the global picture, just give me a minute. If you look at this peak over here, this peak is contributed largely by India. Not a happy situation, but that's a fact. So this is a dynamic graph of how the Indian outbreak moved compared to what we were seeing elsewhere in the world. So we started, our first case was detected in January, and then we started slowly and then started picking up and went up and up till about middle of September. And then our graph started coming down. We went through Dussehra, and when we went through Diwali, and we went through Bihar elections, and the graph kept going down except for a little blip that you see over here. But since the third week of February, we started picking up, and we picked up at a very, very high rate, as you can see. So, why did we get here? How did we get here? This is something that we should look at. If you look at the picture, these are numbers from the end of day yesterday. You will notice that India had roughly 18.7 million confirmed cases and about 208,000 deaths. But look at what I have circled. Yesterday India added 387,000, almost 387,000 cases and 3,500 deaths. Now look at the comparison of India's numbers to the numbers of other countries in both new cases and new deaths. And these are the countries that have the top 10 caseload in the world. So if you consider the whole world as one, the world is putting out roughly 900,000 cases per day, out of which India is contributing almost 40% of the cases. As far as deaths are concerned, India is contributing roughly 1/5 of the deaths. But don't believe these death numbers, because there is something very weird with these death numbers, something very wrong with these mortality numbers. Now, once the outbreak began, and I've shown you this, but again, the daily new cases, our outbreak went down in about mid-February to roughly 10,000 cases per day. But since the third week of February, we have gone into this exponential rise, and not just in the daily cases, but of course the active cases. And the active cases are going up at the rate of roughly 4.5% per day, which is a really very steep rise. And of course, as expected, even if the death rate, the case fatality ratio stays the same, you'll see many more deaths happening simply because you have many more infections happening. And of course, as expected, the death graph is shifted by about 10 days to 2 weeks from the cases graph, because that's how long it takes for a person from infection to death. The problematic figure is here. Green shows new recoveries and orange shows new infections. And as you will see, once the outbreak started peaking out, the difference between recoveries and cases has increased. And this is why we are in a situation like this. All right. This is sort of a graph that gives you a statewide picture. And this is as of yesterday. Of course, Maharashtra is still pulling out the maximum cases, but Maharashtra over the last week or possibly a little longer is showing a dip in its cases, and so is Kerala, where you are located. But look at Uttar Pradesh. Uttar Pradesh has very quickly moved into third position, both in deaths and in cases, and it continues to go up. The 300 deaths in UP is really a joke. 300 deaths are possibly happening in one B-grade city, B-level city in UP. Forget about places like Lucknow and Allahabad that have a massive outbreak happening. The problematic number is this, the test positivity rate. The test positivity rate for India is 21%, which means that randomly, if you test 100 people, 20 are coming positive. 1 in 5 Indians is coming positive at this time. And again, this will also depend upon your ability to test. So if you test more, you will possibly find more. And the worrying aspect, of course, is also this. The vaccination in India has slowed down quite a bit. So by now, we have only given 1 dose of vaccine to roughly 9% of the population. And evidence from other countries like Israel and UK have shown that unless you administer vaccine to roughly 40% of your population, you're not going to be shifting the outbreak curve very significantly. So we seem to be a long way away from there. Now, if you look at the active COVID cases, and this is something I wanted to highlight, the highest rate of active cases is in the Northeast. This is an area that has so far shown very little impact of the pandemic, but this is where the pandemic is really growing right now at a very high rate. And this is of concern, because this is also an area where healthcare facilities are not as good as in some other parts of the country. Now, you've heard a lot about these R values. So an R value simply is an average value. If you have an R value of 1, it means that on average, every infected person is infecting one more person. If the value is 2, that means every infected person is on average infecting 2 others. So at a R value of 1, the outbreak is at an equilibrium. It's neither increasing nor decreasing. So we were at a point where the R value in the country was below 1, and that's when the outbreak was going down. But this is the current situation. For the country, the R value is roughly 1.5. So every 2 persons are infecting at least 3 more on average. But it varies quite a bit. So in places like Assam and Bihar, you see rates of about 2.5%, whereas in Maharashtra, for example, you are just above 1, Punjab, you're just above 1. So it varies quite a bit, and that's also important to understand that you can't really look at India as one entity, because India is many countries in one, and the outbreak is really happening at different levels. It will peak at different levels. All of that will happen. Now, why do I think that India's daily COVID mortality data just does not make sense? So if you look at the graph that I'm showing here, this is the data from World Bank from 1960 to 2019, and these are numbers that the government of India itself gives to international bodies. So the happy thing here is that since 1960, our mortality rate has come down, and these are deaths by natural causes. So it has gone down from roughly 22 per 1,000 people in 1960 to roughly 7.2 per 1,000 people in 2019. So let's rationalize this based on 2019 figures. So 7.2 deaths, natural deaths per 1,000 per year, translates to roughly 27 to 28,000 deaths per day for our country's population today. Now, if you look at the 7-day moving average of COVID deaths per day over the last 1 week, this is roughly 2,700, 26 to 2,700, which means that there is just a 10% increase in daily deaths. Now, if there was a 10% increase in daily deaths due to COVID, this would not even be visible at our cremation grounds, at our burial grounds. So that is why I think this mortality data just does not make any sense. And let me also tell you a personal experience. So this is the photograph of my cousin who passed away due to COVID on 23rd, which is last week. His sample was given for COVID testing on the 13th of April. His results still have not come in after testing. So when he died on 23rd, he was not listed as a COVID death. He was listed as a non-COVID death. And that, I think, is a fundamental problem, that many people are being tested, their results are not coming, and therefore they are not being called COVID deaths. Many people are dying at home, especially in small towns and villages, and we don't even know the level of this calamity that we are facing today. Okay, so one question that people ask is, how long would the second wave last? Now, you realize that all this is based on modeling, and models are based on assumptions, and models are based on data that is present. If the data is not good, models will not be good. This is one of the better models, which is called the India SIM model. And if you see, the dots represent the reported cases, and the model in the first wave has predicted quite well what actually happened. So the blue lines are really the predictions, and the dotted lines is the actual cases. So if we believe this model, then this model is telling us that the peak will be sometime in the first week of May. And at peak, we are going to have somewhere between 4 lakh to about 6 lakh cases per day. There are various other models. There's an international model called the Michigan model, which also predicts the same timing, but suggests that India may have somewhere around 9 lakh cases per day at peak. Well, whatever cases we may have at peak will also depend on how we behave from here on, because individual behaviors, population behaviors cannot be counted for in models. So if we are in lockdowns in many places, and if we continue to mask up and reduce transmission, then the peak will shift down, and hopefully we'll have fewer cases. Okay, let me just say a few brief comments on the virus and the genomic diversity that we are seeing. So as you're aware, this is a coronavirus, which has its closest identity to a bat coronavirus that was first found in eastern China in 2018. There's 96% identity of the COVID virus to this virus. But if you look at the first SARS virus that came in 2002 and 3, there's only about 80% homology and only about 50% homology to the common cold coronaviruses that cause about 20% of common colds annually. This has an RNA genome, which is roughly 30 kilobase in size, makes about 24 to 27 different proteins. And one of the distinguishing features of coronaviruses are the presence of this protein called exonuclease, which is a protein that can correct the errors that happen in the genome. This is a facility not available to any other RNA virus. And that is why the mutation rate of coronaviruses is much lower than other RNA viruses. Okay. This is a picture that you have often seen, and the purpose of showing this is that the virus surface is decorated by one major protein, which is called the spike protein. And the spike is made up of 3 monomers of the spike protein. And so there you have this trimer. And this trimer attaches the virus to the cellular receptor. So the virus binds to the cellular receptor, which is the ACE2 receptor on the cell surface, through these knobs of the spike protein. And if you have antibodies that are directed towards the spike protein, this will prevent binding of the virus, and this will prevent infection. And this has really been the idea behind plasma therapy. This is also the idea behind vaccination, that if we are able to develop neutralizing antibodies against the spike protein, it will prevent the virus from binding to cells, entering cells, replicating in cells, and propagating the infection. Now, genomic diversity, I've already told you, the evolution rate is roughly 10 to the minus 3 per nucleotide per year. And this is for all coronaviruses, not just for this one, which effectively translates to roughly 2 to 3 nucleotides per month in the genome. Now, you might ask, if that is the rate, then how come we see so many variants, so many mutations? And the answer to that is simple. We have roughly 150 million infections by now. So there are a lot of susceptible people, a lot of virus infection has happened, a lot of replication has happened, and therefore this number gets amplified. The other thing to understand about mutations is that mutations is a completely random process, but only those mutations are seen which are selected. there are many mutations that are deleterious to the virus, and therefore they will never be seen. The only ones seen are the ones that offer some benefit to the virus, either by evading immunity or by infecting better or transmitting better. And that is what we are seeing now. So if you start looking at the clades of the virus, and this needs a little bit of an explanation. So if you focus on the upper one here, this is the virus that came out of Wuhan in 2019, depicted by the dark blue circles. But if you see, this virus diverged into another branch on the family tree somewhere around late January 2021. And this happened because a mutation occurred in the spike protein, which is called the D614G mutation, which allowed the virus to replicate better, transmit better, infect better. And therefore, those viruses outcompeted the Wuhan strain. So while you see the Wuhan strain still there, it's only about 1% of the virus transmitting today. 99% of the virus transmitting today is coming from the 614 lineage, and this is all this virus that you see around. Within this lineage have developed other lineages, such as the UK variant lineage, such as the Brazil lineage and the South African lineage, and also the Indian lineage in this, as I will show you in a minute. And if you see on the radial graph here, the closer you are to the periphery of the circle, more recent are those lineages. So, for example, the UK lineage emerged only around December 2020. So did the Brazil lineage, and so did the South African lineage. Now, these are called variants of concern. The B117, which is the UK variant, the B351, which is the South African variant, and the P1, which is the Brazil variant. And as you will see, they have spread around the world at various, in multiple countries at different rates. The black on the map shows regions of the world where the virus is spreading in the community, and the reddish color shows you virus which is replicating, but still not at very high levels across the country in the community. So the UK variant is more widespread, but the South African variant is something to be more concerned about, because this carries mutations that have the capacity to make vaccines lose their efficacy. So, for example, at least two vaccines, the Johnson & Johnson vaccine and the Novavax vaccine, were tested in South Africa and elsewhere, and their efficacy in South Africa was about half of what it was seen elsewhere. So, and that is purely because of the circulation of this variant. Okay. So what about the Indian variants? Now, you may have heard of this term called double mutant. So the double mutant is actually a misnomer. The scientific name for that is B1617. And this is a lineage that carries 15 different mutations that define this lineage. Out of those 15 mutations, there are 6 mutations that are in the spike protein, and 2 of those mutations are in a part of the spike protein shown here in red, which is the receptor binding motif of the spike protein. And these are the 2 mutations that are of concern to us, because these 2 mutations have been shown elsewhere to have varying effects. So the L452 mutation is something that was first seen in humans in California and was responsible for the expansion of the outbreak in Southern California. So this allows the virus to bind better to cells, infect cells better, replicate better. Another mutation in that area, which is called the E484 mutation, is the target of many neutralizing antibodies, and this mutation evades some of those antibodies. There is another mutation that developed primarily in West Bengal, which is now called the 618 lineage, which also carries this E484 mutation, which is a mutation of concern. Now, this really is a dashboard that tells you of the picture in the country at this point. So the group INSACOG, which is the Indian SARS Consortium on Genomics, came about in mid-January, and this is a consortium of 10 labs that has by now sequenced roughly 20,000 viruses from India. And this presents a consolidated picture across the country to show you that various different variants and mutations are circulating in the country. So you have B117, which is the UK variant, 351, which is South African variant. Then you also have 617, which is the Indian variant circulating at various levels in the country. So if I just pick, for example, Punjab, roughly 80% of the viruses that we see from Punjab have the UK variant in them. In Maharashtra, if you start looking, you have both the UK variant and this Indian 617 variant, which was first noticed in Maharashtra and which has grown in prevalence in Maharashtra from about from very small levels to about 15 to 20% sometime in February, and now roughly 40% across Maharashtra, about 60% in some areas of Maharashtra. So we can say that this variant is possibly linked to the surge in Maharashtra, and if it was in Maharashtra, it would also be linked to the surge in various other parts of the country. West Bengal is an interesting case because West Bengal has all the mutants that have so far been found, and I'll show you in a minute. So we do have a consolidated picture based now on roughly 20,000 sequences that are available from India. So this is what I was talking about, Maharashtra. This crimson color, the red color, is the B617, which is the Indian variant. And as you will see, it has grown in proportion from October to December to January, February, and March. If you look at West Bengal has many other variants, including these 617, as well as the newly emerged 618. And by the way, we also know now that 617 is diverging into at least 3 different subgroups, which are being called 617.1.2 and .3. So the virus is quite happily mutating in the country because we are giving it a chance to mutate through all these super spreader events, which include elections, which include religious gatherings, which include large weddings. This is the Bengal picture, and as you see, many different variant lineages are present in Bengal, and this is something to be really worried about because Bengal has gone through a very long election season where all of us have seen hundreds of thousands of people coming into one space, most of them without masks. Even the tallest leaders addressing them don't wear masks while addressing these rallies. So I feel that Bengal is looking at a fairly, shall I say, concerning situation in the days to come. Okay, to happier things, COVID vaccines, this has really been one of the hallmarks of the past year. Many types of vaccines are available. So the traditional vaccines, the inactivated vaccine is available in the form of Covaxin in India, which Bharat Biotech has made. We also have genetic vaccines, DNA and RNA vaccines. Much has been said and written about RNA vaccines, which are the Pfizer and Moderna vaccines. These are not yet available in India. There is a DNA vaccine called the ZyCoV-D vaccine in India, made by Zydus Cadila, which is awaiting approval by the regulator in India. Then we have these viral vector vaccines, which is the Oxford AstraZeneca vaccine, the Sputnik vaccine, and others, which are based largely on adenoviruses. So you know that the Covishield is based on the chimp adenovirus, and the Sputnik is based on human adenoviruses. And finally, we have the virus-like particle vaccines. The only one which has gone forward in this case is a vaccine from Novavax, which is a virus-like particle vaccine, but it has not yet received regulatory approval for use. This is the current picture a few days back. We have multiple vaccines in the pipeline, multiple vaccines that have been approved. And here is a list of all the leading vaccines in the world that includes our own Bharat Biotech vaccine and the Oxford AstraZeneca vaccine, which is called Covishield, made by Serum Institute in India. Now, a question that is in people's mind is, would current vaccines work against the variant viruses that we are seeing? So there is a lot of data already in literature on this. I'm simply putting this picture up to show that if you have mutations at the interface of where the virus binds to the receptor, which is also the site where the virus binds to many neutralizing antibodies, these mutations can be of concern. And some of these mutations include this E484K, the N501Y, and the K417N mutation. There are several others like N440 mutation, which are of concern because they occupy the site where neutralizing antibodies bind. So a paper in the New England Journal summarized this quite well, that variants that have the full set of spike mutations present in the South African variant are likely to compromise vaccines, but isolated mutations are not going to compromise vaccines to such a large extent. And this is some new data from India about the Indian vaccines. This is data that was uploaded on a preprint server on 23rd of April, results of people who have been given the Bharat Biotech Covaxin. If their sera was taken, it neutralized the vaccine strain of virus, but it also neutralized the 617 strain as well as the UK strain, the B117. And if you look at the data closely, you find that the neutralization is compromised a little bit for the 617 and also slightly for the UK, but not as much for the UK as for the 617. But the overall data suggests that Covaxin will still protect against 617. And of course, larger studies are needed to be absolutely sure on this. What about Covishield? CCMB Hyderabad has just put out this data a few days back. This is not a publication yet. This has just been shared on Twitter, which shows data that the convalescent sera from Covishield vaccinated people neutralizes the parent strain of the virus, but also neutralizes 617, although to a lesser extent than it does the vaccine strain. So hopeful news, good news, more to be seen, more to be written on this. What about the rate of vaccination in the country? The rate of vaccination, as you know, vaccination started on 16th of January. For a long time, the vaccination didn't really pick up. And then, towards the end of February, March, it started picking up and picked up quite well in March and April. But ever since the first week of April, vaccination rates have been falling in the country. And, this is both doses, and this is just the first dose. So why is this happening? This is happening because vaccine supplies have suddenly become an issue. Uh, Many more people are going for vaccines, but vaccines are uh, not becoming available. And this is something that has to be sorted out very, very quickly if we are to vaccinate sufficient numbers of people in the country. So, how many people do you need to vaccinate in the country? So, this is something that people have calculated, that if India vaccinated at a rate of about 20 lakh doses per day, to cover 20% of the population, we will take 9 months. If at that rate we wanted to vaccinate 60% of the population, it will take us more than 2 years. Clearly, this is not a timeline that we would like to see. So if we are going to vaccinate all eligible 18 plus population by the end of the year, we have to vaccinate at the rate of roughly 75 lakh doses every single day of this year. Going back to this, what are we putting out now? We are putting out roughly 15 lakh doses. In the best of times, we have gone to about 40 lakh doses. Uh, the average really is roughly in the range of 25 to 30 lakh doses. What we need to do is 75 lakh doses per day, every single day of this year. So this is a very tall task. Uh, the other question which has emerged recently is the price and uh, the action that will follow from here on. There is one price for the center, there is another price for state governments, and the price varies, of course, between the two vaccines. Covishield had announced at rupees 600 for state governments, and I believe just yesterday or day before, they have reduced this price to 300. Now, India, as all of us are aware, is a complex country, and therefore it is good to keep things simple. My worry is that this complexity, center versus state, multiple pricing, uh, some people getting vaccinated at private centers, some getting vaccinated at government centers, it's really going to complicate the situation. And one hopes that these uh, these problems will be streamlined and we can move on towards vaccination at full speed to protect the population. To end, often asked, do masks help? Yes, absolutely, masks help, because if everyone is wearing a mask, the risk of transmission is reduced to only 5% of what would be there if no one is wearing a mask. Should we wear masks even after vaccination? Absolutely yes, because all vaccines, not just in India, everywhere in the world, uh, have been tested not against infection but against disease. So if we get infected, we will also the virus will replicate in our system, and we will also shed the virus. So even though we are vaccinated, we should, in public interest, uh, continue to wear masks. So that's my last slide, and I will be very happy to take any questions that you may have.
That's wonderful, sir. It's a fantastic presentation, touching upon many of the questions that we have in our minds. But here we open the forum for further conversation and discussion. So you may kindly type in your questions in the chat box, and the viewers who are in YouTube and Facebook, you can type in your comments box the questions that you wish. And those who are online, you may kindly notify and ask your question. Well, sir, when others are framing their questions, perhaps I'd like to ask you a question. Uh, it is somewhat like from your presentation, it seems that it looks like that the second wave came all on a sudden. Was there any prediction even in the scientific fraternity? Was there any method to really predict? And was there really any prediction that it is going to come? And was there any caveat issued about what we can do?
So certainly there was prediction that there will be a second wave, but nobody really expected the intensity of the wave to be this much. Nobody expected the surge to be so much that the entire healthcare system would be completely overwhelmed. So you might ask why this has happened, and I really feel that this has happened because we became complacent, we let down our guard. And I'm not, when I say we, I don't put the responsibility entirely on individuals. Yes, individuals are responsible for protecting themselves and not being complacent. But the kind of messages that individuals were hearing was, these messages were telling them that India has conquered the virus has gone away, so we needn't worry. Uh, and that really created a situation for us at a time when the country opened up, at a time when mutants were developing and we were not sequencing at a high enough density to pick them up. So everything sort of came together for us. We opened up the country not just the economy, but we opened the country up to super spreader events. And these super spreader events were the local body elections, these were state elections, and if I may dare say so, the Kumbh Mela. Uh, in the times of pandemics, we should have been a little more careful with these things. We were not.
Exactly. So we have received one question from one of our colleagues, uh, one of our curators, Mr. Shubhashankar Ghosh. He asks that, is there any difference for the effectivity of two vaccines, Covishield and Covaxin, because of which there is such a big difference in price? One is 600 and the other is 1200.
Yeah, so I think this question refers to the price in the private domain. If you're
Yeah.
not getting it through the state or through the center.
Yes.
Well, price of a vaccine doesn't depend on the efficacy of the vaccine. Uh, so firstly, let me explain to you what efficacy really means. And I personally feel that people are running too much after efficacy without truly understanding what efficacy means. So let's say if there is a vaccine that has 70% efficacy, most people think that it means that if 100 people get the vaccine, 70 will be protected and 30 will not be protected. That's the most common thinking about efficacy. But that is wrong. What it means is that if I take a vaccine with 70% efficacy, I reduce my risk of severe disease and mortality by 70%. Okay? And so there is a difference between the two. So the point really is that if there is a vaccine with 70% efficacy and a vaccine with 80% efficacy, all of them are significantly reducing every individual's risk of getting severe disease and dying. So the simple point is, go take a vaccine, the vaccine which you can get most easily. Don't go after the best vaccine, because we don't even know what the best vaccine is. So remember, these vaccines have not been tested long enough for us to be answering that question. At this point, we know that all of these vaccines will protect against severe disease and mortality 100%. So just go and take whichever is easily available.
So you mean right now we are not in a position to choose. Our first
No.
priority will just to protect any sort of way we can.
Right.
Okay. And then, sir, we have another question by another of our senior curators, Mr. Saju Bhaskaran. He asks how sure we are that this virus is really airborne, and if it is so, then what are the impacts?
Right. So this is something that WHO has put out recently, and this is based on cumulative evidence over the past year. Remember, last year we were telling people that the virus is present in droplets, and the bigger the droplets, more virus in those droplets, and those droplets will drop quickly to the ground. So you need to really sanitize surfaces much more than worry about aerosols. Well, the transmission pattern of the virus has allowed people over the past 12 months to look at data and come to the conclusion that surfaces do not pose as big a problem, and the virus is airborne. Now, what does airborne really mean? Airborne doesn't mean that the virus is lurking outside your door, and the moment you step outside your door, the virus will catch you. It also doesn't mean that you can keep your windows shut because the virus will come into your window. No, what it simply means is that if you are in closed spaces, if you are in a closed room, if you are on an airplane, if you are in a bus with all the windows closed, if you are in a car with all the windows closed, and in all these conditions, if there is recirculating air and there is an air conditioner on, and if you're not wearing a mask, and there is one person in that system who is shedding virus, there is a high chance that you will get the virus. Okay, so that's what it means. So what is the best precaution against that? The best precaution against that is let natural air flow through your offices. Let natural air flow through closed spaces as much as possible, and the virus is not going to catch you. Of course, continue to wear masks because masks are very good protection. So, this message that went out that the virus is airborne, I swear, some of my neighbors have closed their windows. They're not opening their windows. And that's completely wrong perception. In fact, opening the windows allows fresh air to come in and allows the circulation of fresh air, and that reduces the risk of getting infected.
So, I think what you are trying to say is that dilution of the viral load concentration is the absolute necessity.
Absolutely, absolutely.
And that is the impact that we should look for, not anything else.
Right, right.
Okay, that's fantastic. So I'd like to ask you another question that since you have talked about many of the variants that we already have in India, and is it the reason that in India, since the spreading is so fast and we are allowing it to spread so fast, the more we allow it to happen, the more mutations are likely?
Absolutely. The more opportunity you give the virus to mutate, to replicate, to multiply, the more it will mutate. Simply because mutation is a random process. Every time the virus replicates, virus multiplies, mutations happen. Now, there is of course a limit to this because the virus cannot mutate indefinitely. The virus can only mutate to a certain point beyond which any mutation becomes bad for the virus itself. So whether or not viral mutations have saturated, we don't know the answer to that. But certainly the more we give an opportunity for the virus to multiply, the more it will mutate.
So do you suggest that focusing on the intensity points, controlled lockdown can be a good solution towards approaching the immunity from this virus?
Yeah, so any means that will prevent gathering of many people in one location, anything that will reduce population density uh, in any space is going to help. Lockdown does that, containments do that. So you have to really isolate people who are infected from those who are susceptible. So all of these are strategies to do that. Well, we have seen the lockdown that happened last year, and certainly the lockdown led to a situation where we controlled the intensity of the first wave. Our first wave could have been much worse if we didn't have a lockdown at that point. But then, the lockdown had its side effects. It devastated the economy, it devastated livelihoods. So I think we've learned something from that. And possibly what we have learned is to do things in a more controlled manner now, and have more region-specific lockdowns instead of locking down the entire country at once. Yeah.
So about these variations, what sort of physiological changes do you anticipate when they mutate so much and they interact with us? And will it reflect in terms of newer sort of symptoms in the patients?
Well, these are things that can't be anticipated. These are things that have to be studied. So I think it's very important that there is correlation between the genetic sequence and the clinical symptoms. We can't let that not happen, because only by correlating them we will know whether this is happening or not. But there is no way to predict it.
So more intensive studies will be required for this.
Absolutely.
And connecting to this, I have another question asked by one of our colleagues, Mrs. Jyoti Mehra. She asks that the efficacy data that we see, do you think that they are based upon significantly good sample of data so that they can be relied upon?
Yes, I think so. The phase 3 trial of any vaccine that determines its efficacy is done on thousands of volunteers. And if I recall correctly, Covaxin was tested on, I think, 26,000 people. Half of them received a placebo and half of them got the vaccine. And then, 2 months after the last dose was given, efficacy was tested. So Covaxin, I think, if I remember correctly, Covaxin came out with a 81% efficacy at the 2-month time point, and some recent analysis has dropped that efficacy to 78 or 79%. But again, I will say, efficacy was done in a clinical trial. Efficacy is always done under controlled conditions of a trial. That does not always translate into a population. Secondly, efficacy is only limited for the period for which it was studied. So if a vaccine has 80% efficacy, that means that the efficacy is during the period of the trial. And if the period of the trial was, let's say, 3 months, that is efficacy data for 3 months. That is not necessarily the efficacy data for 6 months or 1 year or 5 years. So we have to really understand what efficacy really means. Effectiveness is a more valid term. And for effectiveness, it's important to do post-vaccine surveys to see how the vaccine is really working in a population, in a field situation. And those studies are more valuable than simply efficacy.
So do you expect that the way it peaked very sharply, the exit peak, I mean, the exit slope would be equally steep, or it is going to be slower than that?
Uh, the exit is usually slower than the rise. Uh, Remains to be seen. Again, it depends on our behavior and containment, and vaccine rollout is not going to make much difference on this wave, largely because if you start taking a vaccine today, it takes at least 6 to 8 weeks before you get full protection. So, since only about 9% of the population has received one dose, and only 1.5% of the population has received both doses, vaccines will not make much impact on the second wave. It will make some impact, but it won't make much of an impact. But vaccination today is going to decide you know, when the third wave will come and what will be the intensity of the third wave. So please don't take my comments uh, selectively to say that vaccines will not, uh, alter the second wave. Vaccines are required, vaccines should be taken, and vaccines will alter the course of this pandemic. But I'm not sure that they will alter the course of this wave in such quick time. Uh, but please go ahead and take a vaccine.
Okay. Sir, another question we received is, do you anticipate that exercise, yoga, or the natural food kind of solutions can have any effect on this infection?
No, no, absolutely. I mean, anything that increases your immunity will help. So, whether it is yoga, whether it is breathing exercises, whether it is foods that increase your immunity, whether it's doses of vitamin C and vitamin D, whether it is zinc, all of those increase your immunity. But you have to understand that all those are non-specific. They will not work especially against the COVID virus. Uh, it will, in general, raise your immunity. Breathing exercises are very good because they increase the health of your lung. They increase your lung capacity, and if you have better capacity in your lung, you will be able to handle the infection much better. So all those are useful. Please go ahead and do all that. It improves your general well-being.
So we have recently heard about a CSIR sero survey among its own people, where they claim that it is found that even 80% of the people who were infected did not develop sufficient antibody. Do you think it is likely, or I mean, what is the real interpretation of this case?
Well, I haven't seen their data, to be honest, so I can't comment on that. But you know, protection uh, is not just based on antibodies. Protection is also based on cell-based immunity. Uh, and antibodies will protect from extracellular viruses that have not gone into cells yet. But antibodies cannot enter cells, and therefore they will not protect against viruses that have already gone into cells and replicated. However, T cell based immunity will identify infected cells and kill those cells, and therefore destroy the reservoir of infection. So, both arms of immunity are important. Uh, so, just don't go after antibodies. They're a good measure, they're a good measure of the immune response. But I'm not sure whether the number is so high as 80%. I would expect the number to be a bit lower, uh, much lower actually. And
Okay.
antibodies also wane with time. Uh,
Yes.
so, but even if antibodies wane with time, our immune system creates a memory, and that immune memory is recalled very quickly when the next infection happens. And that's how we are protected by both vaccines and natural infections. Yeah.
So, do you think that even after one has got infected, one should take the vaccine?
Absolutely. Absolutely. And that is the protocol. Uh, if you get infected, that's like one dose of vaccine. In fact, it's much better than one dose of vaccine because some vaccines may not give very good T cell immunity, but infection gives you very robust T cell immunity. Uh, but yes, the protocol is that even if you have been infected, you should get both doses of the vaccine. Uh, and I don't recall exactly what the guideline is, but possibly 3 months after the infection, you can start your vaccination.
Okay. Sir, another question we received from Mr. Mainuddin Ansari. He wants to know on what basis researchers declare about a new variant. Is it only genetic change or some morphological changes involved as well?
Genetic changes. I mean, the morphological changes are so minor, you won't even be able to see unless you do a X-ray structure of the virus. But based on genetic changes, so a lineage really means how multiple mutations have come together in that lineage. Uh, there are individual mutations, there are 2 or 3 mutations coming together. But when many mutations come together, that becomes a lineage. All mutations may not be important for immunity, just like in 617, there are 2 or 3 key mutations, but otherwise there are 15 mutations in that lineage. So to answer your question, it's genetic changes, not morphological changes.
So, is it safe for the patients with CKD or cancer or any such comorbidity to take the vaccine? Is it safe? Is it okay?
As far as I understand, yes, because the Bharat Biotech vaccine is a killed vaccine, so the virus will not replicate. The Covishield is not a killed vaccine, it's a viral vector vaccine, but the virus vector will go into your cells and it will just produce the spike protein. That virus will also not replicate. For people who have immunodeficiency or people who have cancers, a replicating viral vaccine would not be something they should take. But in that sense, both of these vaccines are not replicating viral vaccines.
So, it would be better to have a clinical advice in such cases.
Absolutely, absolutely. In all those cases, and also if you have an underlying comorbidity like cardiovascular disease or diabetes, you should always consult your physician before you take this vaccine or that vaccine.
So, even in our council, we have heard a few cases where a person has got reinfected.
Yes.
Is that a possibility? Can it happen? And
No, absolutely. Absolutely, it happens. Because remember, I told you in my presentation that vaccine efficacy has been tested against disease. It has not been tested against infection. And there are many other vaccines that protect against disease. They don't protect against infection. And a very good example is the seasonal flu vaccine. The seasonal flu vaccine does not protect you from infection. It protects you from flu. And so is this vaccine. Even after you take the vaccine, if you're not masking up, if you're not careful, you may get infected. But after infection, you will either be asymptomatic or you will have mild disease. You will not develop severe disease.
So, the viral load may be considerably lower.
Yes, absolutely.
So, I understand that you have a following meeting immediately. So,
yes, I do. Yeah,
I'll just end up with one last question.
sure.
It is related to our field, and I understand that you were also working for a long time with the Welcome Group, who are very good in documenting
Right.
such pandemics and all such cases. I'd like to ask you one question. Do you really see any good effort all over India to document this pandemic so that once again, if we have to face, we will really know what we did last time, where we went wrong, and what we can do much better in the future?
Well, I mean, I'm not following this very closely, so what I say may be completely wrong. I only know of one effort that is trying to do this, and that is the Bangalore Science Gallery. Uh, the Bangalore Science Gallery is organizing a 3-month online exhibition which is called Contagion. I can send you the link to Contagion. Over 3 months, they're going to have multiple talks and live demonstrations, exhibits, and it is not focused entirely on COVID, but it's focused on similar issues. But beyond that, I don't really know.
On the global scale, is anything happening like that?
Oh, I'm sure Welcome is doing things. They are very good at these things. But again, I don't know the answer to your question, honestly.
Okay, sir. Thank you so very much for spending so much of time with us
Thank
and
you.
giving so nice and detailed, patient answers to all our questions, which sometimes may even be naive. But even then, thank you so very much. I think you are already praised for your next
Yes, yes.
meeting.
Thank you, Manas, and thank you everyone
Thank you
for.
very much, sir. We
Thank you.
expect that in future also we may talk once again whenever you
Certainly.
can give us
Sure.
some. Sure, sir.
Goodbye.
Thank you. Thank you very much. Thank you.